Welcome to the development phase of this project. This phase of development is after testing and running the already built code. In development phase, we write the code from scratch. So starting from the very base, we need Visual Studio Code. We have other options as well, but I will be following Visual Studio Code to download it and work upon it. You can simply go to its website, download the Debian version or Windows version. I am working on Linux, so Debian version, and install according to the instructions that are provided. Once you have that, you are going to be opening up a project. I have mobile robotics basic folder already added into my workspace. You can add the one that you created. Before just starting, all of the code that lectures are being recorded accordingly is in the course development branch. This branch is going to contain section wise uploading or pushing of the code. Now let's see what the work is. We'll need to create the project using Platform.io, which is going to be installed using the extensions in VS Code. You just search for Platform.io and install it. Once you have done that, you go into the extension, create a new project. It is going to be Wi-Fi controlled robot. The board we are going to be using is Duet ESP32 DevKit v1, and framework is going to be Arduino. We don't want to perform right now for the basic projects. We are going to be using Arduino, not the ESP IDF. Default location is going not to be utilized. We are going to go inside Luqman, and I have mobile robotics basics, and here you are going to create the project. Finish. It is going to take some time on your system for downloading the ESP32 relative libraries and extensions. Now you can see it is appearing in this area. It also added it as another folder. I will remove it from here. Now we can see that this untracked new file has been produced because I am continuously syncing. I also have added a git ignore the do not upload .pio and VS Code the build files and stuff. Let's go into the source folder, main directory, and this is the basic code that they have provided that performs some function. Now, if you want to work with Platform.io, we need to open Wi-Fi controlled robot. Currently, we are not accessing Platform.io stuff. So add a folder, and the way it was done earlier, we have to do that. Just open this, and we have to remove this folder. And now it can see that platform ini file is in the workspace here. So it is loading the Platform.io related stuff. So we can now perform this build option. I will click it to start building for the ESP32. What it does, it actually starts building the main CPP file, and whole project included stuff is going to be built using this Arduino H. It has been successfully built. Now if I connect my ESP32, this is complete robot, but still we are just accessing ESP32, and I upload the code using this forward arrow, and it compiles it, and now you can see it has started the upload. But in your case, it might not happen. In my case, it has successfully uploaded the code. In your case, if it is not uploading, or the first time it will not be uploading, you have to first check if the device is connected. How you do that on Linux is list dev tty USB 0. If it is not available or any other USB 1, 2, 3, 4, then it is not connected. In my case, USB 0 is connected, so that's why I am getting it. Other thing that permission issues come on Linux, you have to fix by following any tutorial online. Permission denied on this and fix port on Linux. The Arduino one is the best one that you can find, and you need to set group dial out, and it is going to allow the USB communication. User mode AG dial out username for Linux users only. Here in this case, my username is Luqman. Here I will write sudo username -a -g dial out and Luqman. Then it is going to dial out. I need to restart the computer, and then I would be able to access my USB. If still it doesn't work, you can find out different tutorials and make it work. Now let's look at this small example of code to start blinking the LED. Now let me paste the code that I have already written. It might not work like this, but to simplify, let me replace it with just 2, which tells us that this is the pin number 2. Upload this onto my ESP32. So at this point we can see the code is working in Arduino format and we are able to utilize platform IO and upload it into our microcontroller.